So if you have a flat mirror and you want to draw the the object that you see, you want to draw what the image looks like and where it will be placed, and we can use the angle, the law of reflection, which is if any light ray that's emitted from this object hits this mirror, it's going to bounce off at the same angle that it hit it in regards to the normal. So let's have a look at this. So if I take the object and I draw a light ray that's going directly perpendicular to the plane of the mirror, it's going to bounce back at the same angle. So it's going to bounce back directly back off the mirror and past the object. Now, if I was to look at that light ray, so if I looked down the path of that light ray, my brain would actually think that the light ray originated from the other side of the mirror, because it doesn't initially look at the flat mirror and think that that's where the light originated from. So it thinks it came from behind the mirror. So that's how we would observe it. Now, just if we took another light ray, because the light rays come off this object in all different directions, so when any light hits this object, it bounces off and is dispersed in all different directions. So if we look at another light ray going off it, say at this angle here, so we can use the rule. Now we can really understand how it works is that if this light ray approaches the mirror at an angle to what we call the normal, which is a perpendicular line drawn through the plane of the mirror where it hits. So if this angle here that we have is called the angle of incidence, or the angle of it hitting the mirror, the angle of incidence will be equal to the angle of reflection, the angle that is reflected back. Now, what that means is, again, if I was to have my eye and I saw, so if I moved my head and I saw the light ray, I would think that it came from behind the mirror. So I draw a back ray to show it coming from behind the mirror. So you can see the back ray from a light ray bouncing perpendicular off the mirror, and the back ray for a light ray bouncing at this angle off the mirror intersect at a given point. Now the point of intersection is exactly where the image will be. And it doesn't matter what angle I draw the light rays coming off here. So if I draw one down here and then it came off at exactly the same angle, the back ray is always going to meet at this one point, and that point is where our image is. Now, just one further point, the object is said to be real because it's in the real world. Now, the image that we see on the other side of the mirror is called virtual. So we have a virtual image. Note here that this image is the same distance away from the plane mirror as the object is, and it's directly perpendicular or across from the object on the virtual side of the mirror. So let's take this and see if we can actually just simply draw the image of a... Okay, so here's a diagram, a light diagram that we're going to draw. This line in the middle represents the plane mirror, and I've got a lightning bolt on the left-hand side. It's a complex object to draw reflected, but what we're going to do is we're just going to break it into components. So the first component, we're going to take the top corner here of this lightning bolt. So this is the object on the left-hand side. So I'm going to draw a perpendicular line through the plane mirror. Okay, and then the distance from this point here on my lightning bolt to here, I'm going to call D1. And then I'm going to draw a line exactly the same length along this perpendicular line on the right-hand side, on the virtual side. And here it is here, and this is D2. Now, at the end of D2, I'm going to draw a dot, or sorry, a cross. And this cross represents this point being reflected on this side, because we know from our previous slide that the reflected image is the same distance away from the plane mirror on a perpendicular line, right? So we just go through and do that for each other point. So each of these points in this object. So I'm going to take this point here, and then the one just dipped in there, this point on the edge here, this one just dipped in, then the one down on the at the bottom here, and then I'm going to go back to the other side. Now remember, for each one of these points, I've worked out exactly, I've got a perpendicular line. I don't have to draw it. I can use the lines of reference, and I've drawn for this part here across exactly the same distance on the other side. And then I'm going to draw one for this one, and then I'm going to draw one for this one, and this one, and then the last one is going to be this one. So I've now drawn all of these points. Now, if I want to draw this complex image, all I need to do now is just connect the dots in the same way that it is in the object. So I connect the dots, here they go, and I'm just going to shade them in. And there we go. This is our lightning bolt. It's been reflected. This is our image. This is our object. Remember, on the left-hand side, this is the real object, and this is the virtual image. Now, what was important here is this rule here, that the distance D1 equals D2, and that we draw a perpendicular line. Don't forget, if you found this helpful, this video, if it helped you out in drawing reflected objects, don't forget to recommend it to others, other people, and gives the video a thumbs up. Thanks very much for listening, and I'll see you on another time.